Okay, so finishing up finding our mass on this torque ladder example. We had rearranged for mass, and now we were filling our numbers in, and we were on this bottom term, and the R for the person was 3/4 of 12 meters. He was 3/4 of the way up. So that should be 9 meters. So 9 meters. And the angle for the person, here's the R, here's the F, it's this angle, that one's 60, so it must be 30. Okay, and then you need to try to type this into your calculator correctly to get an answer. And if you do, I'm looking for my answer, you should get, now the way I have rearranged it here, the top is negative and the bottom is negative. So if you do it, the bottom, the top should be negative 11.5692 meters per kilogram, and the bottom's actually negative 0. Did I lose a mu? I did. 0.4 goes here. I only lost it and this row to this row because it was off the screen. So it's the bottom is 0.343, and it's also negative. Okay, and when you do this, you should end up with a mass of 33.7218 kilograms for the mass of the person. Okay, so wasn't that fun? Now you need to try it. So I want to give you 2 to try. So this one's going to be example number 2. So you're going to need to actually write it down for me, okay? Because you don't have it there. It's not on the back of the sheet. We'll go to the back of the sheet in a second. So it's a ladder making an angle again at the base of 60 degrees. It's a nice uniform ladder. Its length is 10 meters. And its mass is also 10 kilograms, just to keep the numbers easy. Coefficient of friction at the bottom of the ladder is 0.2. And the person climbing the ladder this time only gets 1/3 of the way up. Okay? So the R for the person is 1/3 of 10 meters this time. And do I need to give you anything else? I don't think so. Find the mass of the person. Okay, so when the videos are finished, I want you to do this one. I also want you to do on your more torque question sheet. I want you to do number 6 because it's another one like this. So example 2 and number 6, both of them are finding mass. Okay, the answer to this one in the end will be 117.45 kilograms. Okay, shh, don't tell anyone, but see if you can get it. All right, the last thing I wanted to talk to you about with these questions, and then the next video I'll talk about the lab a little bit, is the back side of the sheet I gave you, which is friction at the top of the ladder. So only after you've mastered the mass ones, then I want you to just try this one. We will do it together in class because it's really easy to get stuck in an endless loop. But this time, besides having F normal of the ground down here and F friction of the ground down here and the weight of the ladder and the weight of the person and the F normal of the house, this time you're going to have a friction of the house acting up. Okay? So give it a try. You're still going to do exactly the same steps. Some of the forces in the X direction, some of the forces in the Y direction, and some of the torques. I would suggest still picking your torque, your pivot point down here. The only thing you have to be careful of is where you're subbing, because you can easily get subbing into get caught in this loop. Okay, so give it a shot. Don't get frustrated. Don't spend 5 hours on it. Give it a shot to see if you can find. You still want to find the friction at the base of the ladder. Okay, so have fun. It'll be good. and we'll go over it the next day I see you, and we'll do another one like it. So the 3 questions you're working on, example 2, that is this picture, number 6 on the back of your sheet, and the back of your more torque questions, and this friction at the top of the ladder. You also have a lab to work on, which I will talk about in the next video.